Welcome or welcome back at C Square. In this lesson we'll talk about pyramids first and then about cones. And you see here a pyramid is a polyhedron, how we call it. The faces are triangle and the base depends what kind of polygon you have. All these triangles meet on one common point called the vertex. The volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. You see here the formula. The lateral area, you can approach it in two different ways. One way is to look to the faces, those triangles I mentioned before, count how many you have, find the area of one triangle and multiply by how many you have. Another thing that you want to be aware, that height of the triangle, it's called the slant height. Like this segment you see here, this is what we call the slant height. Okay, which you need it to find the area of one triangle and then multiply by how many triangles. However, there is another way to do it, which you see it right here. The lateral area, those triangles, you can find it by just doing 1/2 times P. You may want to put a capital P here, which because it stands for the perimeter, and L stands for the slant height. Okay, the surface area is the lateral area plus 1 base. So let's see this example here where we have to find the volume and the surface area. We're going to start with the volume. If you remember, the formula is 1/3 area of the base times the height. The base in this case, if you notice, it says a square pyramid. So if this is 10, this is 10, it's because it's a square. You have two choices, 10 times 10 or 10 square. Either way, it's giving you 100. And now we can go and find the volume, 1/3 times the base, the area of the base, times the height, 9. So here I will simplify, 3 goes in 9 3 times, and 100 times 3 is 300. Just to be sure, 300 cubic units. So it depends what unit you have. That is the way you measure the volume. Let's move to the surface area, but I'm going to start with lateral area. If you remember the lateral area, we have two choices. I'm going to use that formula, 1/2 P times L. If you remember, P stands for the perimeter. What is the perimeter of the base? This base is a square, side by 10, so simply 4 times 10, 4 sides, each on 10. So it's 40. The thing that we really need to work and find is what we call the slant height. I'm gonna draw one of them, and I think this one is the best to be drawn. So you can see this slant height is perpendicular on this side BC, and these two guys meet in the same point. And if you take a look to that triangle, that is a right triangle. And because this is 10, this is half 5, just 5 here. And this is 9. So we need to find this slant height, the L I call it. We can use Pythagorean theorem, a squared plus b squared equals c squared. We're gonna have 9 squared plus 5 squared equal L squared. And we have here 81 plus 25 equals L squared, or L squared, the slant height, equals 106. So to find L, you have to just take square root. And I'm going to leave it like that. It cannot be simplified, by the way. And I'm going to go back and I'm going to do the lateral area now. 1/2 times the perimeter, which is 40, times the slant height, square root of 106. If you notice now, we can simplify like this, and the final answer for the lateral area, those 4 triangles, 4 faces, it's 20 square root of 106. Last step here, last part in fact, surface area is the ladder area plus, again, just one base. A pyramid doesn't have two bases, it has only one. So we have here lateral area 20 square root of 106 plus this 100, which is the area of the base. I'm gonna leave it in this form. If you need to evaluate, obviously you need the calculator and put it in the calculator. My second example, very similar. However, what is different, you notice now we have this segment, we do not have the height. This is the slant height. So it makes sense to start here with surface area. I think it's easier. And again, I'm going to start with lateral area, which is 1/2 P times L. P in this case is the same because it's still a square and the side of the square is 10, so the same math. And the slant height is given now to us is 13. So the lateral area will be 1/2 times 40 times the slant height, which is 13. We're going to simplify here, and we have 20 times 13, and that means the lateral area is 260 square units. Remember, area measured in square units. We can move to the surface area, which is the lateral area plus the base. We know the lateral area, we just found it. But what about the base? The base is that square. We had it in the previous problem, 10 by 10, so 10 square, and that will be 100. So the surface area will be 260, the lateral area plus 100 plus that base, and that will be 360 square units. And now we can move to the last part, which is the volume. So you see I start with the last part in fact, and I'm moving to volume now. Okay, for volume obviously we need this height, VE. Now if you notice, this is the triangle we had before, a right triangle. If you remember, this is 5, half of this 10. The question is how much is this height? And again, I'm going to draw this triangle here. 5, 13. If you remember, this is a special set of numbers, a Pythagorean triple, how we call it, 5, 12, 13. It's good to remember something like that. If you do not remember, obviously you can use a squared plus b squared equals c squared, and you will have 5 squared plus b squared equals 13 squared. If you do this math, you're gonna get this 12 for b. But now we know the height, it's 12, so we can move to the volume, which is 1/3 area of the base, capital B, times the height, and we know everything here. 1/3 times the base. The base, if you don't remember, we have it right here, 100, and times the height. The height is this 12. So again, we can simplify here, and we have left 4 times 100, which is 400. The volume of this square pyramid is 400 cubic units. On my next part of the lesson, we'll talk about the cone. And you see, we have here a right cone, how it's called. The formula for the volume is the same, 1/3 area of the base times the height, the same with the pyramid. The only difference, if you notice, the base is a circle, so we have this pi r squared here times h. So if you remember this formula, that's great. If you don't remember, it's the same like the volume of a pyramid. Surface area, if you take a look here, this is the surface area, the yellow sector, let me call like that. This arc here, it's exactly the circumference of the base, and that allows us to go and get this lateral area, which is pi RL. And the surface area will be a lateral area plus the base. Okay, so, and by the way, this is the formula where we replace everything with what we have, pi RL, the lateral area, and pi r squared, the area of the base, in case if you remember this formula. So let's see an example here. Now we need to find the volume and the surface area in terms of pi. So we're going to start with the volume here. If you remember, it's 1/3 area of the base times the height, so the same like the pyramid. The only difference, the base now is a circle, so the area is pi r squared, and the radius is this 5. So we have pi times 5 squared. We don't really need parentheses here, but I just want to show you how we replace r with 5. So the area of the base is 25 pi, leave it like that in pi. And let's move to the volume, which is 1/3 times this 25 pi times the height. The height is this 9. So here I guess also we can simplify like this, and we have 3 times 25, that is 75 pi cubic units is the volume of this cone. Now let's move to the surface area, and the first thing I'm going to do is the lateral area. If you remember, the lateral area is pi RL, a formula that I think is very useful if you remember. R is the radius and L is the slant height, this segment VA, or V and this one here, but I think it's better to see this one because now you can see this right triangle, and this is 9, this is 5, right? And I think we had the same triangle on the first example. So if you want to review, this is 5, this is 9, this is going to be the slant height we did on the first example, and we end up with square root of 106, the same math. So now we can move back in the lateral area, and we have pi times the radius, which is 5, times the slant height, which is square root of 106. This is a good answer. The only thing probably I will do, I will rearrange it like this, 5 pi square root of 106, and this is the lateral area of this cone. What about the surface area? Very similar with what we did before. We have the lateral area plus 1 base. We have this 5 pi square root of 106. We found out just a minute ago. And the area of the base, if you remember, we did it here, is 25 pi. I'm going to leave the answer exactly like this. You cannot combine these two expressions. The only thing you can do is just factor out of 5 pi if you want, but I think I'm going to leave it like this. This is the surface area. If you need to evaluate, obviously you need a calculator. On the next example here, very similar. I want you to take a look. The slant height is given now, and that allows me to find very fast the surface area by starting with, if you remember, the lateral area is pi RL, so it's going to be pi times the radius, which is 7 in this case, and L is 25. The slant height is given to us now. So we have just 7 times 25, I think that is 175. 175 pi. This is the lateral area of this cone. And for the surface area, we're gonna have to do the lateral area plus 1 base. So the base, like I said, is a circle, so we have pi r squared, and the radius is 7 if you remember. So this area will be 49 pi. So we can go back here and we have 175 pi for the lateral area plus 49 pi for the base. If we add this, we're gonna get 175 plus 49 is 224. 224, don't forget the pi. Square units, very important again to remember the unit for area. Now we can move to the first part of the problem, which is the volume. And the volume of a cone is 1/3 area of the base times the height. We did the base right here, 49 pi. We need this height, which is this segment. VO is this segment that is perpendicular on AB. This is a right angle. So we need this guy. And that will be 7, it's one leg, 25. And if you remember, there is a Pythagorean triple, 24. 7, 24, 25. If you remember that, then you can get the H very fast. H is 24. If you do not remember that, you can use a squared plus b squared equals c squared, and you replace 7 squared plus b squared over h squared equals 25 squared. If you solve this one, you're gonna end up with 24. So we can go back and replace, and we have 1/3 times the base. The base is 49 pi times the height, which is 24. I think we can simplify here. 3 goes in 24 8 times. So we have just 8 times 49. And that is 392 pi cubic units. Okay. On the next problem, we go back to a pyramid, and what do we know? We have this pyramid which has a volume of 1275 cubic centimeter. You notice the unit, and the base is a square, and we need to find, and we need to find that side if we know that if the height is 17. Okay, so we have here the formula, volume equals 1/3 area of the base times the height. So we need to find the side, and we have here the volume 1275 equals 1/3 times the b. The b is the thing we need to find out first, and the height is given, it's 17. So in this problem, first of all, you want to solve for b, and for that reason I will suggest you to multiply by 3 to get rid of this 1/3 and divide by 17 to get rid of this 17. Obviously you have to do the same thing on the other side, divide by 17 and multiply by 3. So now let's see what we get. I'm gonna grab a calculator and I'm gonna do this math on the calculator. 1275 times 3 divide by 17 and up to 225. That's the area of the base. Now the base, which is a square, right? Let's call this S or L. The area of the base is S squared, or S times S. So that means S squared equals 225. So for finding S, you have to take square root of 225, which is not super complicated, I think. We end up with S equals 15. The length of a side of this square is 15 centimeter. The height is 17. The volume of this pyramid will be 1275 cubic centimeter. A very similar problem. The volume now is 720. The base is also a square pyramid with a side of 12. Now we need to find the height. So I'm going to set up something very similar. We have 1 over V equals 1 over 3 area of the base times the height. And now we know the volume, like in the previous problem, 720 equals 1 over 3. And we can find this B, the area of the base. Why? Because the base is a square and the side is 12. So we have 12 times 12 or 12 square, and that will be 144. So that is going to go here. And I need to find this H now. So if you remember, what have we done in the previous problem? We multiply by 3 because you want to get rid of 1/3 and divide by 144 because you want to get rid of this 144. So don't forget to do the same thing on the other side. Divide by 144 and multiply by 3. So that is how much the height is. I'm going to grab my calculator and I'm going to do this math. 720 times 3 divide by 144, and I end up with 15 centimeter is the answer for this problem. The height of this pyramid is 15 centimeter. In my next example, we have a cone, and we need to find the diameter of the base of this cone. If the volume of the cone is 50 pi cubic centimeter, and the height of the cone is 6 centimeters. So the same thing, we're going to start with the volume equals 1 over 3 area of the base times the height. We know the volume, it's 50 pi equals 1 over 3. The area of the base, we do not know it, so that's the thing we're going to need to find out, times the height, which is 6. So in this equation, we're going to find this B. So I will do something very similar we did in the other problem. Multiply by 3 to get rid of the 1/3. Divide by 6 to get rid of the 6. The same thing on the other side. Divide by 6 and multiply by 3. So we have B equals, keep the pi there, it doesn't bother us, you'll see it, 3 times 50, 150, divide by 6, that will be 25 pi. The area of the base is 25 pi. Well, of course, we don't need that, we need a diameter. So for that reason, we're gonna need to do a couple more steps. First of all, remember, the base is a circle, pi r squared. And the base is 25 pi. We found it. And that's the reason I said leave the pi there, because now we can do this simplification. You can simplify this pi like this or divide by pi if you want, and you have r squared equals 25. So now how do you find r? Just take square root of 25 and that will be 5. The radius is 5, however we need to find the diameter. One more step. The diameter will be twice the radius, so it's going to be 2 times 5. The diameter will be 10 centimeter. A very similar problem, we need to find the height of the cone below. if the volume is 600 pi cubic centimeter and the circumference of the base is 30 pi centimeter. So if we go here to the volume, we start with the volume, 1/3 times area of the base times the height. We notice we have a problem if we replace, which I'm going to do it. We have 600 pi, the volume, equals 1/3. We do not know the area of the base. We know the circumference of the base is 30 pi, and we do not know the height. In fact, the height we need to find out. So how are we going to find the area of the base which we needed here? We're going to start from the circumference, which is 30 pi. And remember, the circumference has a formula, 2 pi r. So basically now I'm going to take this 30 pi and replace this c here. So I have 30 pi equals 2 pi r. Like in the previous problem, you can simplify the pi. And you have 2r equals 30. Divide by 2. And we have the radius now. Radius is 15. We're going to need this radius because now we can find the area of the base. B, it's a circle, pi r squared. So we're going to have pi times 15 squared. 15 squared is 225. So the area of the base is 225. Now we can go back here and use this 225 now. Pi times the height. The height, remember, we need to find out. Okay, so my first thing that I will do here will be to simplify this pi. Remember, if you have something like that, you can do it. And then you want to solve for h. Let me copy this one more time. 600 equals 1/3 times 225 times h. So how are we going to solve for h? If you said, oh, it's multiplying by 3 because you want to cancel this 1/3, that's correct. And then divide by 225, that's correct also. So divide by 225 on the left side and multiply by 3. And we have the height. I'm going to use a calculator now. And we have 3 times 600 divide by 225. And I end up with 8. The height of this cone is 8 centimeters. And this was the last problem in this lesson. If you enjoy this lesson, don't forget to click the like button and come back on C Squared for more help. Thank you.